In this video, you are required to find the focal length of the converging lens over here. And you have a mirror at this side here, a converging lens, then followed by the object. And this is the position where you place your eyes. And there are two ways. Basically, you can actually shift the lens to the right or left so that the image form is perfectly in line and also the size are identical. So, or you can also shift the position of the object to the right or to the left so that the image form is exactly the same size and is in line with the nail when you tilt your eyes forward or backwards. One thing to take note that when you have adjusted the lens or the object such that the image and the nail is in line and they are of the same size, the distance x and z, they are actually not important. So that means to say, if I were to shift the mirror forward nearer to the lens or even just beside the lens, it won't change the position of the image or the nail or the object. And likewise for your eye distance from the object, if you can put your eyes forward or backwards, it doesn't make a difference as long as you can see clearly. One common mistake by students is when they see that the image and the nail, they are of the same size, they will kind of think that this will be scenario 2 where the object is at 2f and they know that the image will be exactly at 2f and they are of the same size. So this is 2 times the focal length. But you have to take note that the image and the object, they are different side of the lens. For this case, the object and the image, they are on the same side. So if you were to think of that way, so your focal length naturally will be y divided by 2. But of course, if you look at the option here, it's not one of the options. So obviously, this is actually wrong. Now, let's recap. If you have a principal axis here, and this is converging lens, you have parallel beam of light, okay, parallel to the principal axis. After passing through the converging lens, it will converge to a point. This will be known as the focal point, and the distance from the optical center all the way to the focal point, that will be your focal length. So basically, this is similar to this. So right now, the light ray from the tip of the nail, the object, after passing through the lens, it will be parallel as long as you achieve that the alignment of the image and the object is in line and they are of the same size. That means to say, after passing through the lens, the ray will be parallel to the principal axis. So the mirror, it doesn't matter what the position is, the purpose is to reflect the light back along the same path. And since light is reversible, this will be true also. So that's why the image of the nail will be formed here. So this, if you understand this diagram here, this is exactly the same. You just treat as parallel beam of light coming into the lens. After that, it will be refracted, converge to this point. So this distance here will be known as focal length. So B will be the answer. Now, some of you might ask, how do you know it will be inverted? So if I were to, let's assume for this case, x and y, they are exactly the same distance. That means to say this will be your f at this point. So this is f also. So if this is the head of the object here, parallel to the principal axis, after that, it will pass through focal point. Okay, so it will obey the law of reflection. Then after that, it will be parallel to the principal axis and then it forms here. So what about if the mirror is shifted here? If that's the case, these two rays will be the same. So it will still pass through here, obeys, this will be the normal, obeys the law of reflection, after which it will continue to be reflected and then come to this point. So hopefully this will help to explain how do you know why the image is inverted.